So in this lecture, we're going to be discussing the second part of measures of association or measures of effect. So as I highlighted yesterday, these slides are not my slides. I adopted them from Dikwebra, from Charité University in Berlin. So today we'll finish the other. In the first lecture, we discussed the relative risk ratio measures, where we discussed relative risk and odds ratio, where we say relative risk, they are used for case control, for case relative risks, they have cohort studies, but odds ratio, we use them for case control studies. We discussed the formulas on how these how we calculated this in the previous lecture. Today, we are going to discuss the attributable fraction and population attributable fraction, then attributable risk and population attributable risk. So these measures of effect, as I said, usually there's a it might be difficult to distinguish in terms of the terminology, because some of the terminology they are used interchangeably. What we'll be discussing today, the attributable risk and attributable fraction. In some literature, these are really called measures of impact, because impact, now we are looking at the population level, in terms of relationship between exposure and outcome in terms of causing disease. So what are these attributable measures? So first, we have what they follow into two groups. We have those which looks into the exposed group, and those which looks in the whole population. So in terms of in the exposed group, we have got the attributable risk. So the attributable risk, this is the formula. The attributable risk is the incidence in the exposed group minus the incidence in the unexposed group. So that's the formula for attributable risk. So incidence, and I hope you remember from the last lecture how we are calculating this, where we are saying incidence in the unexposed and incidence in the unexposed, where we are looking in our 2x2 table. We look the number of those who have disease among those who are exposed. This is then we get the incidence and it among exposure. Then incidence in the unexposed, how do we get it? We get the number and the total number of who got the disease in those who are not unexposed. Then we divide by the total number of unexposed to get the incidence in the unexposed. So that difference now, that's the attributable risk. So the same applies to the population, which is the population attributable risk. So by population attributable risk, we are saying incidence in the population minus incidence in the unexposed. So incidence, if you remember our 2x2 table, we have the total population which we are using. So I think you need to understand that formula now to say, in terms of the incidence in the population, is the combined incidence in both exposed and unexposed over the total population. And this is of if you remember 2x2, I remember it was that area where we got the total population. So that would be the population, and we have got our incidence in exposed. Then we've got relative measures, where we can then also have the attributable fraction and the population attributable fraction. This is just a percentage now, where we are converting the above risks as a population of the total incidence in the whole population. So just to explain further on the attributable risk calculation, attributable risk is calculated by subtracting the incidence in the unexposed group from the incidence in the exposed. So that's the formula. So you can have it as an attributable rate or attributable and as a risk difference. So if you're using risk difference, usually is when you calculated it mainly from risk data. But if you're using the person time data, it then becomes rate difference. Remember, it can only be obtained from code data. Why can you only get this from code data? Because it's about incidents. Other type of studies which are not codes, it's difficult, which are not code studies, you'll not be able to calculate incidents, like in cross-sectional studies, so you can't. So the attributable risk, you can only get it when you are using code data. So you can calculate it either using risk data, or it can be calculated where it is called a risk difference, or it can be calculated using percent time data where it becomes a rate difference. So this is the and how these two can actually be presented in form of a diagram. We've got our exposed group and we've got the unexposed the unexposed group. Then in terms of the incidents now, let's say it's smoking, whatever we have, whatever exposure which you are exposing. The incidence in the exposed group, and if whatever we're exposed to is the risk factor, it means the incidence of what outcome will be looking, it will be very high, more than the incidence in the exposed. That difference now, that difference of risk between unexposed and the exposed, it becomes the attributable risk, and what we're measuring is the incidence. So that's how it's so attributable risk among the exposed, what does it mean? It is the risk in this exposed group that is due to the exposure. And that is the risk in the group, or that is the contribution of the exposure in causing the disease and in the exposed group. And remember, as I said, if you look, it doesn't really mean some conditions might still occur and even in the unexposed group without the exposure of interest. But usually, as I mentioned, if whatever you're exposed the people to and it is like a risk factor, you expect to have a difference between the unexposed and the exposed and unexposed. In that difference now, that is the attributable risk. So in other words, it is the amount of disease incidence in the exposed that is due or attributed to the exposure. And so remember, one of the most interesting things we need to understand now, and if the exposure could be removed, and if the exposure could be removed, our attributable risk is the incidence among exposed that could be prevented if you remove or eliminate the exposure. And then by that, we're just calling that an absolute risk reduction. What is the amount of risk which is going to be reduced if we remove the exposure? So that is the attributable. So I think it's the same from this graph where we're comparing our exposed and our exposed and unexposed. And this difference now, that's the attributable risk. Then we have got, now we are moving from the attributable risk to the attributable fraction. So the attributable fraction, now this becomes a fraction. So a fraction, it means there's dividing. So it is a ratio of the attributable risk and the incidence of the exposed and the incidence of the exposed group. So it's just the same formula, incidence in exposed, incidence in unexposed over the incidence of this. Then you get your what. There are also these other formulas which you can use this one and this risk difference, and this one attributable risk difference over the incidence, or you can also calculate it using this other formula, relative risk minus 1 over RR or odds ratio minus 1 over R. These are the formulas which can be used. But usually this is then expressed as a percentage and is multiplied by what? By hundreds. So in terms of the definition, what is the attributable fraction? This is the proportion of cases now. Is the proportion of cases among the exposed that is attributable to the exposure. So that's the attributable fraction among the exposed group. What is the percentage or what is the proportion among the exposed that is attributable to the exposure? That is your attributable fraction. Or it can be defined as the fraction of disease in the exposed group that could be prevented if the exposure was eliminated. So it's more or less the same thing, but in this case we're just converting. And the first one, it was a difference, and the risk difference between exposed and unexposed, and you just get that amount of exposure. But that amount of exposure can be converted into a percentage now, and it can be changed into a percentage. Remember, this is the same. This is the same. The attributable. This minus this. That's your attributable risk. But if you put this as a denominator, it becomes a percentage. And this one is your attributable risk or your risk difference. And if you then just, which is this on top. So if you just put the exposed, it becomes a percentage. So you're just converting that attributable, that risk difference into a percentage so that you see the proportion of cases among the exposed that is attributable to the exposure. So I think we've discussed this in one of the lectures in terms of the interpretation, where you can have an exposure which is protective. So I think we discussed this in terms of interpretation, where we say you can have whatever you're calculating as 1 minus 1 or above G or above 1. So both, I think that's really whether something is a risk factor or is a protective factor. It's just to summarize it, and it's just to summarize what this slide is all about. Just to try to say, at times an exposure can be a risk factor or can be a protective factor. If you then calculate your relative risk, your attributable risk or attributable fraction, it might then actually be negative, as opposed to being a positive, because in this case the risk, the incidence in the exposed will be lower than the incidence in the unexposed. So this concept is often used in clinical trials, where in most cases now, most treatments which are given in clinical trials, some of the things they're given to prevent a negative event. So because of that, you can have this, where this attributable fraction, it can be negative, or because of these issues of either risk or protective factor. One of the examples which this concept of attributable fraction is used is on vaccines, and it is on what is on vaccines, where we really want to determine the efficacy of vaccines or the effectiveness of the vaccine using the same principle, the same wording of exposed or unexposed, and those who are not unvaccinated, unvaccinated population, that's the exposed group, which means they're at risk of getting disease, whatever the disease might be, whatever the disease the vaccine might be working against. Then the vaccinated population, these are what are unexposed, which means they are not at risk of developing the disease. Using the same principle as an example, like for polio, in terms of polio vaccination. So the incidence of polio among unvaccinated is 57%. Incidence of polio among vaccinated is 16. So those vaccinated, they have a lower incidence as opposed to those who are not vaccinated. Using these two, we can actually calculate the attributable fraction. That using this this concept, which you can then use to, which we can then convert it to then assess what is the efficacy of the vaccine. So this is the formula and for attributable fraction and the incidence in exposed minus incidence in what in unexposed over the incidence in the exposed times what 100%. So the vaccine efficacy is what, if you multiply this by this by this, you get 100%. So from the attributable fraction, this is the number of cases that can be prevented if the exposure is removed. So which means in terms of vaccine efficacy now, it becomes 71.9% based on this principle. So this whole concept of attributable fraction can be really used to interpret or discuss issues to assessing how vaccines are performing. Then, so I think this is enough of the attributable fraction. Now we're going at population level. Remember, that's why I said these measures of effect or measures of association, whatever, you might see where they are mentioned is, where they are highlighted as measures of impact. Why? Because at impact, you're looking at population level. And this, what is the contribution for the impact of whatever exposure you have at population level? So the first one is our population attributable risk. How is it calculated? It is calculated by subtracting the incidence in the unexposed from the incidence in the total population. Exposed plus unexposed. Remember, I explained this. Maybe I need to look for a 2x2 table where I can just show you. But I think I explained this to say your total incidence in the population, you are counting the incidence both in exposed and unexposed. And your total population, if you remember in our 2x2 table, that's your A plus B plus C plus what? Plus D, that's the total population. And your incidence is both of the cases and in either exposed or unexposed. That's your population incidence. And your instance in unexposed, this is easy, and because you can get it. So your population attributable risk, it becomes incidence in the population minus incidence in unexposed. And this is the formula which can be used, where you can use the attributable risk times the prevalence. And we can actually get your population attributable risk. These are the formulas which you can also memorize. They can become very handy when you are doing multiple choice questions. We can bring some of these questions. So what is population attributable risk? It is the amount of incidence of a disease in the population, both exposed and non-exposed. That is due to what? To the exposure. So I think the difference is, just remember, in this case, we are looking in the whole population as opposed to looking in the separate categories. So it is the excess risk of disease in total population attributable to the exposure. So it is also the disease incidence in the population that could be prevented if the exposure was eliminated. So that's where the whole issue of that's the whole issue of public health. Most of this intervention, we are really looking at population level. Because remember, it's all about really preventing some of the exposure so that we can reduce the disease. So it is the reduction in risk which should be achieved if the population is entirely at what? And it is unexposed. And as I mentioned, with the population attributable risk helps in determining which exposures are relevant to community, to public health within the community. So I'll try and give you examples on how to calculate these things. Because as I'm explaining them, they're a bit complex, but if you're working them out using those 2x2 tables, it will be easy for you to understand. Then it's the same formula if it's for your fraction and for your fraction now, where you're now expressing it and it is a percentage of the total risk within the population. That's the same. So our instance in the population minus our instance in the exposed over the instance in the total population. And these are the alternative formulas which you can memorize. So it's more or less the same, but what is now different, the other one is in the exposed, but in this one, we are looking in the total population, where some might be exposed or others might not be exposed. So I think just a repetition of the formula, our proportion now, PAF is the proportion of disease incidence in the population, both exposed and exposed, that is attributable to what? To the exposure. Or is the population is the proportion of disease in the population. So for PAF, for attributable fraction, is in the exposed group, but for population attribution is the proportion of disease in the population, not the exposed group. That could be prevented if the exposure was eliminated. So in terms of terminology, as I mentioned, these are some of the, for the attributable risk, there are other terminology which are often interchanged, which are often used, or they're interchangeable. You can see people calling it risk difference because there's difference between exposed and unexposed. Risk difference if you're using absolute numbers. Rate difference if you're using percenting. If you're using percentile data, so you end up getting the rate difference. Then it's the absolute risk reduction, excess risk, or excess incidence. Remember, the word excess, why is it coming excess risk? Is because we are comparing the risk in exposed and the risk in what? In unexposed. So because of the difference which will then happen in those two, whatever difference is then due to the excess risk or excess incidence, whatever is happening. But if you then reduce that, which is absolute risk reduction, if you then reduce that difference between the two, then you might actually be able to reduce the risk of getting the disease. That's where the absolute risk reduction term comes. So these words are interchangeable. You may, as I mentioned, they are often said. Then attributable fraction, some of the terminology which is used, it can be called etiologic fraction, it can be called attributable risk percent, because you are converting the attributable risk to a percent. It can be called an attributable proportion or attributable risk fraction. So these are some of the words which can be used to describe our attributable fraction. So I think it's just a recap again in terms of our formulas and where we have got attributable risk, population attributable risk, we have got absolute, which are difference measures, and we have got relative risk, which are now proportioned, either within the exposed or within the population. So if you look at it in this now, just to conclude this whole thing which you're discussing, if you're comparing measures, you can have absolute or relative, or you can have differences or ratios. If you're comparing for differences, these are risk difference, attributable risk, and our population attributable risk. Then our ratios, whatever you calculate, we have our relative risk, our odds ratio, our attributable fraction, our population attributable fraction. Because now there's the element of dividing so that you get all these things in. So in terms of whether you use relative or absolute risk, really, you cannot really say this one is the best in terms of which to use. Why? Because they provide different messages. I think you understood from the way you were describing this thing to say these things, they provide different information. So you cannot really say either I stick to relative, either I stick to to relative measures as opposed to to this other. But each of these measures, they provide different messages depending on what you are assessing. I think I gave you an example of vaccine efficacy, where you can actually use attributable fraction to refer to vaccine to vaccine efficacy. So the absolute effect measures, they measure the effect of exposure on the population. Then relative effect measures, they measure the extent of which the disease among exposed is a consequence of the exposure. So in general, relative measures, our relative risk, they often look more impressive than absolute measures, and it's our absolute risk. So the lower the risk and or rate in the control group, the larger the difference between risk reduction and risk difference. So at times, it depends with the type of study or the type of analysis which you're doing. It might be advisable to report both, because if you then report both, it kind of really assists in giving a clear picture. In giving a clear picture. So I think this slide brings us to the end of these measures of association, measures of effect, or measures of impact. As I said, these words might be used interchangeably, but actually they don't really mean mean the same. And some of them, the impact one, they refer to population level. Where the other ones, they just refer the relationship between exposure and outcome without really looking into the population. So you get some questions, for you to practice so that you understand these things better.